maths with matrices. Okay.
Okay.
Matrices is plural form of matrix. So let us understand this matrix. What is it? Matrix is just a rectangular arrangement of elements. Okay, matrix
Yeah.
is rectangular arrangement of elements, or we can say when we arrange elements into rows and column, then this form is said to be matrix.
Okay.
Okay, for example, let matrix A having elements like A11, A12, A13, A21, A22, A23. Okay, so this is rectangular form of rectangular arrangement of element. Okay, and we can
Okay.
say also elements are arranged into rows and columns. Okay,
Yeah.
horizontal arrangement is said to be row and vertical arrangement is said to be columns. These are, we have two rows. Okay,
Okay.
and we have here three columns.
Yeah.
Yeah, so we can write here these are rows and these are columns. Okay, what it mean by A11, A12, A13? It represent A11 means element of first row and first column. A12 means element of first row and second column. A13
Yeah.
means element of first row and third column. Similarly, A21 is element of second row and first column. A22 is element of second row and second column. A23 is element of second row in or
Third
and
column.
third column. Okay,
Yeah.
you got it now?
Yes, ma'am.
Okay. Now let us understand order of a matrix. Order of matrix is equal to number of rows into number of columns. Here we have two rows and three columns. So we read as this is order. Order is 2 by 3. Don't read as 6. Just read 2 by 3. Okay. Order is
Okay.
2 by 3. Got it?
Yeah.
Now let us learn next type of matrices, because as I told you, matrix is singular and matrix is plural form. Types of matrices. First type, row matrix. In row matrix, we have only single row. We can have as many as column, but having only single row. Okay, for example, matrix A is equal to having one row having this element ABC, or having one another matrix like having 2 7 9. Okay, we can have
Yeah.
more example also, like we matrix Q having only two elements like X and Y. We can have as many as columns but having only single row, then this matrix
Okay.
is said to be row matrix.
Mm-hmm.
Next type, column matrix. Similarly with column matrix, if we have single column and can have as many as rows in column matrix, like matrix X is equal to having elements X, Y, Z. We have three rows but only single column. Matrix B is equal to having elements 1, 2, 3, or we can have matrix C is equal to like 4, 5, 8, 1, having these elements. So obviously we have only single column, okay, and we can have as
Yeah.
many as row in column matrix. Now let us do next type, that is square matrix. In a square matrix, we have equal number of rows and columns. Here we have equal number of rows and columns. For example, like matrix A have elements A, B, C, D. We have two rows and two columns. The matrix V, we have like A1, B1, C1, and A2, B2, C2, and A3, B3, and C3. Okay, so these are example of square matrix. Got it?
Yes, ma'am.
Let us do next one. Diagonal matrix. In diagonal matrix, we have only elements non-zero and all other elements are zero. What it means, I'm explaining you. Okay. So in diagonal matrix, we have only diagonal elements non-zero and all other are zero. So let us understand, we have diagonal matrix B is equal to, this is also a square matrix, okay? Diagonal matrix is also a square matrix. So diagonal element like we have A, B, C, this and other are 0, 0. This is diagonal, okay? So diagonal
Okay.
elements are 0 in diagonal matrix and all other elements are 0.
Hmm.
Yeah. Now let us learn the next type, scalar matrix. In a scalar matrix means a scalar matrix also a diagonal matrix. So obviously this is also a square matrix in which diagonal elements are same. Like we have
Okay.
any scalar matrix P and we have like diagonal elements like 5, 0, 0, 5, and
So
Q,
different.
yeah, having like X, 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 the same elements in diagonal.
Hmm.
So then we say this is scalar matrix. Got it?
Yes, ma'am.
Next type is identity matrix. Sixth type. Identity matrix is always denoted by I. We can't use any other letter to denote it. We use only I for identity matrix, or you can say unit matrix. And this is also a type of diagonal matrix in which diagonal elements is only one, like this.
Okay.
1 0 0 0 1 0 0 0 1. Okay, so these are
Okay.
examples of diagonal matrix. So sometime they can means ask you I2. I2 means you need to take 2 by 2 identity matrix and I3.
Okay. Okay.
Okay,
Okay.
I3
Hmm.
means you need to take 3 by 3 order of
Means
identity.
definitely it should be three. Okay.
Yes. We usually use this symbol I, but sometimes they can give you. Okay, so we need to understand that this is 2 by 2 order of identity matrix and this is of 3 by 3. Okay,
Mm-hmm. Yeah.
okay. Now let us do null matrix or zero matrix having all elements 0. Null matrix or zero matrix. It can have any order, okay, not only square. It's all elements are 0 and we can take any order, okay? And it is always denoted by O.
Okay.
O is equal to like having this order. So,
Zeros.
yes, having all of its, it can be square or non-square both. Okay?
Okay.
And we have some special type of matrices also. We'll do later because we before that we need to understand some operation on matrices. Then we'll do them. Only
Mm-hmm.
then we can understand like matrix addition, matrix multiplication, and transpose. Then we'll understand that. So let us do few means operation before that. Then we'll understand them. Okay.
Okay.
Now let us do transpose of a matrix. So, transpose of a matrix means just convert rows into column or columns into rows. So, if we have like matrix A is equal to having elements A1, B1, C1, A2, B2, and C2, and we need to find its transpose. So, transpose of A is matrix A is usually denoted by A and take here T. And in some book they can use this dash or this symbol also, but most common is this. Okay?
Okay.
A. And to find transpose, just convert rows into column or columns into rows. So we are just converting rows into column A1, B1, C1, A2, B2, and C2. Okay?
Yeah.
This is transpose of matrix A. Sorry, 3 3 here, my mistake. So, oh, sorry, I'm forward. Sorry, this is C2 only, not 3 images. C2. So, this is required transpose of a given matrix. Got it now? You got it?
Yes, ma'am.
Hello?
Yeah.
Okay. Let's do operation on matrices. So, operation on matrices. First, let us do addition, and you can understand addition, subtraction, multiplication by using example. Well, okay. So let us
Yeah.
take two matrices like first A, and remember one thing: to add or subtract two matrices, their order must be same. Only then we
Yeah.
can subtract or add.
Yeah. Got it. Yeah.
Yeah. So we have matrix having elements 8, 7, 4, 3, 1, 2, and matrix B is equal to having 2, 5, 6, 4, 7, 8. We have this. And we need to find A plus B. And so let us add these both matrices 8, 7, 4 and 3, 1, 2 and plus. 2, 5, 6, and 4, 7, 8. So now let us add corresponding elements. Corresponding elements is 8 with 2, 7 with 5, 4 with 6, 3 with 4, 1 with 7, and 2 with 8. Are you getting?
Yes.
Similarly, we do with in subtraction also. So let us add the corresponding elements.
Okay.
So 8 plus 2, 7 plus 5, 4 plus 6, 3 plus 4, 1 plus 7, 2 plus 8 we have. So let us find 10, 12, 10 again, and 7, 8, and 10, which is required sum of matrix A and B. Okay, this is required
Yes.
sum of A and B. You got it now?
Yes, ma'am.
Okay, so now let us do the next operation. So let us understand by using an example. Let matrix P is equal to having elements 15, 19, 12, 7, 5, 4, and matrix Q is equal to 9, 4, 5, 3, 2, 1. And we need to find difference of P and Q. So let us find it. So write down P first. 15, 19, 12, 7, 5, and 4, and minus 9, 4, 5, 3, 2, and 1. So now let us find the difference. Just subtract the corresponding elements of Q from elements of P. So 15 minus 9. Are you getting this? 19
Yes,
minus
yes, ma'am.
4, 12 minus 5, and 7 minus 3, 5 minus 2, and 4 minus 1. So we have the result 6, 15, 7, 4, 3, and again 3. This is P minus Q.
Mm-hmm.
Got it?
Yes, ma'am.
Do you want to ask anything till here which we have done?
No, I'm clear, ma'am.
Sure. Okay. So let us do now multiplication. Multiplication is completely different from addition and subtraction. To multiply two matrices, we need like a equal number of columns in first matrix should be equal number of rows of second matrix. Okay, I'm telling you like if we have x having elements like 4, 5, 3, 2, 7, 1. So we have here like three elements, or you can say three columns here. We have three columns.
Yes.
So in second matrix, we can have as many as row in first, okay? But we have here three
Mm-hmm.
columns. So there should be three rows in next matrix, means in second matrix. So 2, 5, 7, 8, 9, 3. We can
Yes.
have as many as column in second, but it must be
Okay.
equal to number of rows. Means here we have three columns, so we must have three rows here. Only
Okay.
then we can multiply them, otherwise we can't. Okay, why? I'm telling
Okay.
you why. Because we multiply like these elements to these
Two
elements.
first.
That's okay.
Um,
How? 4 with
4 into
multiply
2.
with 2. Yeah, 4 into 2, take plus sign, then 5 into 5, Take plus sign, then 3 into 7. Are you getting this?
Yes,
Are you
ma'am.
getting?
Got it. Got it.
Similarly, just multiply this row with this column also. In similar
2
way,
into 8.
4 into 8 plus 5 into 9 plus 3 into 3. Now multiply this row with first column, then second column.
Second.
Okay?
Uh,
Now 2 with 2, 7 with 5 plus 1 with 7. Similarly, 2 with 8 plus 7 with 9 plus 1 into 3. So 8 plus 25 plus 21 and 4 plus 35 plus 7 and 32, 54 and 9 and 16 plus 63 plus 3. This will be product of x and y. We are finding here x into y. Okay, so what will we get? 8 plus 25 plus 21. We have 54. Then 32 plus 54 plus 9. We have 95.
uh,
And 4 plus 35 plus 7.
36.
And then 16 plus 63 plus 3. We have
82.
82. Okay.
Yeah.
So here in product of two matrices, we'll get order means number of rows will become like on first matrix and number of columns will be according to second matrix. So here we have two rows in first matrix and two columns in second matrix. So obviously we have here order of 2 by 2. Are you getting?
Yes, ma'am.
Yeah. So now you got it, matrix multiplication.
Yes, ma'am. I got it.
Okay. Now let us learn the next topic of matrix. Just looking in your syllabus. So okay, you have only matrix topic, and we need to do all of its topic in it. Just okay.
But why we cannot multiply similar with similar elements, ma'am? I missed it.
This is rule to multiply matrices. This is rule, or you can say this is formula to
Oh,
multiply matrices.
okay, okay.
Yeah, yeah. So next, means they didn't give us matrix inversion yet. So they given us only matrices and matrix operations only. So obviously we have done operation like addition, subtraction, and multiplication only. Okay.
Mhm.
So because in in matrix we don't have division operation. Okay. We just
Okay.
find the division as like if we multiply like if we divide a into b, if we need to find, just find a into b inverse by taking negative power. Okay, by using this way.
Yeah.
So you have only these operations. So shall we do the next topic now?
Yes, ma'am. Yes, ma'am.
Okay, so let's start the vectors first because the next topic in your syllabus is linear dependence and independence only for means this are for vector sorry for vectors as well as for matrix. So we'll do together this, okay, along with vectors.
Okay.
So let us do vectors first. So what is vector? Vector means like any physical quantity is said to be vector quantity when it has magnitude along with direction. What it means? Like if we have line segment, okay, it has no direction, and we have vector along with direction. This is of also like This line segment of like 3 centimeter, 3 centimeter, and this is also 3 centimeter. So this is a scalar quantity because it doesn't have like direction. So any physical quantity which has direction along with magnitude, magnitude means numeric value, okay, is
Okay.
said to be vector. Okay.
Yeah.
So any vector can be represented in like Cartesian plane. Cartesian plane, you know very well, like where we draw the graph having x-axis and y-axis in two-dimensional space.
Hmm.
Okay, and in
Yeah.
three-dimensional we have z direction also, or z-axis also. So in 2D, how can we represent a vector in 2D? Like we have x-axis and y-axis. You know, means this unit length is said to be I, and this unit length is said to be J. So we can represent like any vector, like we have vector here. Okay, we have a
Yeah.
vector having in any direction. You can use this or any any direction. I'll tell you how can we find the direction of a vector later. So if we have any vector here, so here we have like a, I'm telling you, like we have 2 and 3, so we have here distance 3 along y-axis and 4 along x-axis. 2, 3, 4. So how can we represent this vector? This vector, because its distance from y-axis means along y-axis is 3 and along x-axis is 4. So we can represent this vector v as like 4I, because I is unit vector. Like if we measure any distance, length or anything, so we use a unit like meter, centimeter, inch, any. So obviously to measure a vector, we have a unit. This unit like along the x-axis we have I, and along y-axis we have j, and along further we'll do for in three dimension. Then we'll have along z-axis we have k also. So any vector can be represented in this form. Okay, and standard form is of a vector. You can denote a vector by using u or by using v, and it can be represented by ai plus bj, where a b are constant values. Here a is 4 and b is 3. Are you getting this point?
Yes, ma'am.
Yeah. And in 3D, how can we represent it
Okay.
in three dimension? Like we have x-axis, y-axis, and also z-axis. We have here unit length I, and unit length here j, and here unit length k. We have any vector here in space. Okay. Obviously,
Okay.
in three dimension we have anything in space only. So if we have here 3 point on x-axis and 4 on y, and let us 2 on z, sorry, 4 on z, sorry, and 2 on 2 unit away from y-axis. Here we have vector v. So how can we represent this? By using unit vector like 3i plus 4j, sorry, plus 2j, because y-axis here, okay, we have only 2 unit here. Sorry, uh, 2j and plus 4k along z-axis. Are you getting this point?
Yeah. Very good.
Yeah. So in this way, we can represent a vector. Now
Okay.
let's learn a vector dot product because we need only dot product because in vector we have different products like dot product and cross product. So we don't use in data science cross product. We use only dot product in this. Okay. So that is why
Okay.
let us learn that. So we need to take another white word because we have completed 12 pages. So let us
Yeah.
take the next one. Actually, I'm taking your one-to-one class right now. That's why we are going fast.
Yes, ma'am.
Okay, then a batch because only explaining it to you. And if you have any doubt, then I'll explain who only for you. That is why we are going fast. That's
Yeah.
good because these topics are already covered in batch. That is why.
Okay.
Just a second.
These are all I think we have studied intermediate, but we have forgotten somehow. When you're
Pardon?
explaining, I'm recalling. No,
Yeah.
all these topics we were studied in intermediate, man. We forgot, but when
Yeah.
you are explaining, I'm able to recall.
Yeah, yeah, I can understand. Yeah.
Yeah.
Obviously, we have done already. So
Yeah.
it's good. So now let us do the dot product. Okay.
Yes, ma'am.
So,
Do we have geometry in this portion, ma'am?
no, we don't have here because
Okay.
only we have representation of vectors. Okay.
Okay.
In geometry,
Okay.
not, yeah, nothing else more.
Yeah.
So now let us learn dot product of vectors. What it mean? Like in dot product, when we multiply I into I unit factor, we have one. Similarly, j into j we have one, and k into k we have one. And anything else other than these three, if we have I into j, we have zero. Also j into k, we have zero, and k into I also we have zero. So when we multiply two vectors, so we'll get result according to that. For example, we have
Okay.
vector u is equal to 2i plus 3j plus 4k. And vector v is equal to 5i plus 2j plus 7k. Now let us find u dot v. So 2i plus 3j plus 4k into 5i plus 2j plus 7k. So now we'll multiply only I to I and j to j and k to k. Okay, because other than that we'll get 0. So obviously just do directly by multiplying coefficient of I, j and k itself. So we have 2 into 5. Obviously, because we have I dot I, obviously we'll get 1 here. So no need to write I square here. Are you getting?
Yes, ma'am. Got
So
it.
multiply 2 into 5. Or just you're going to use by using dot also, okay?
Yeah.
2 dot 5 plus 3 dot 2
Little three,
plus 4
four,
dot
seven.
7. So we have 10 plus 6 plus 8. So we have 44. Okay?
Okay.
So in this way we can find product of factors. Let us learn the norm of the vector. Okay. And you can give me if you have any assignment or any kind of any document from which you got from any your university, then you can show me so that I can see the pattern and
Mm.
can give you practice material also. That is
I
why
will
I'm
check,
asking.
ma'am. I'll check
Sure,
with them and let you know.
sure, sure. Because vector any topic is very broad, but we don't know how many like topics we need to cover. Okay,
Yeah.
we are doing which are necessary, which are
Yes,
important in
yes.
data science. We are doing all of these. Even then
Got it.
we don't want that any topic will left, obviously.
Got it. Got
Okay,
it.
that is why. And we'll also give I mean, I'll give you also a study practice material according to that.
Okay.
Yeah. So now let us do the norms of vector. Norm means length of a vector. The norm of a vector. We have here four types. Okay. Give me a moment. I'm just opening some material so that we can take some example. Norm is a measure of size of a vector. And we have three types of norm. Like first, Albert norm. or we can represent it like in this way also. I'm telling you. A norm is a way to measure size. Size is less length of a vector because we have only length in vector. Okay, vector. When we do for matrix, then we'll define for matrix also. Okay. So
Okay.
this, if we have any vector in two-dimensional or in three-dimensional, we have vector like this from origin to having a length, and this is vector v, and so this length, like this length is said to be norm of v. Okay, this length. So it means this is a way to measure size of a vector. Okay. So we have
Yeah.
mainly three types. First is L1 norm. Okay. First of all, let us learn the properties of norm. Then we'll do types. Properties of a norm of a vector. First property is non-negativity. What it means? Norm is always be non-negative. Norm should be always non-negative. And we can show this by mathematically, like and my mistake. It is denoted by norm is denoted like, by like this symbol. We have vector v, so its norm is denoted by this symbol. Okay, by
Okay.
using this one.
Okay.
So now it should be always non-negative, and we can express mathematically like norm of v must be greater than or equal to 0. Obviously non-negative. Got it?
Yes, ma'am.
Next type, next property we have second one, definiteness. What it means? It is zero means norm is zero when only we have zero vector. Okay, it is zero only when vector is zero. For non-zero vector, it can't be zero. Okay, so this is definiteness when vector is zero only. So what it means? So norm of v is only zero when v is zero. Okay,
Yeah.
for non-zero vector, it never be zero. Next property is triangle inequality. So the norm of a sum of two vectors is no more than the sum of their norms. What it mean I'm telling you, okay? Their norms.
Yeah.
Means their individual norms like this. Uh, Triangle inequality we can show as if we have two vectors like we have u and we have v. So we add vectors in this way, okay? Just join their ends. So obviously we have u and we have v and this is u plus v only. So when we find u, norm of u plus v, and this is always less than or equal to norm of u plus norm of v. Because obviously we have greater length of some of their individual than this one. Got it? Because
Yeah.
we add vectors in this way only. We just add their ends to add them.
Okay.
So this is
Okay.
triangle inequality. You got it?
Yes, ma'am.
Okay. So we have one more property. Fourth one, homogeneity. Multiplying a vector by a scalar multiples the norm of the vector. I'm telling you what it means. By absolute value of scalar. What it mean I'm telling you. So when we multiply any scalar means which quantity which doesn't have direction, okay? When we multiply a scalar to a vector, then we'll find its norm. Then norm will be this product will be absolute means just multiple of absolute value of that scalar, or we can define as like we are multiplying this lambda to a vector v, okay, and we are finding its norm. That will be equal to the multiple of this absolute value of lambda. Meaning is this. Are you getting?
Yeah.
So these are four properties of norm of a vector. Now let us learn its type. First, types of norm. The first type is Alvan norm. First type L1 norm or Mahaban norm. So L1 norm, if we denote a vector in this way in 2D, usually we denote this. We have vector here like this u having like v1 and v2. This vector we are taking v having component v1 v2. Then how can we find? So L1 norm will be just this distance. This is u1 and add this distance. This is V1 and this is V2. To find norm of means L1 norm of this vector. This is L1 norm denoted by this symbol. Just take one at suffix and that is equal to the absolute value of V1 plus absolute value of V2. Got it? This is
Yeah, ma'am.
L1 of given vector. Now let us learn the next. Or if we have n components, not only two, if we have n components, then we can define by using the symbol L1 norm of any vector can be found by using summation I is equal to 1 to up to n, because if we have n components
Yeah.
and absolute value of xi. Like if we have in 3D, like we'll add then absolute value of 3, like v1 v2 and v3, and having an in up to, I mean we'll add up to another component. Okay,
Okay.
so this is the main formula, standard formula you can say, for to find L1 norm. Got it?
Yes, ma'am.
Now let us find L2 norm. And another name of this is Euclidean norm. This is shortest distance between origin and vector. This is shortest distance between origin and vector. Like if we have vector in this plane and having here vector v having component v1 and v2. So this is the shortest distance. This is okay. We have this v1 and v2. This okay. This distance is v1 and this is v2. So we'll find this shortest distance. This one is L2 norm.
Yeah.
So let us find by using formula. So L2 norm of factor V is the square root of V1 and absolute value of V1 square and plus absolute value of V2 square. Okay, this is the shortest distance. And by using distance formula, as we have done in like unit classes, we have done this. This is same as. So you got it? L2
Yeah.
norm. And one type we have more, and it can be defined for n components. We can use this standard formula like square root of summation I is equal to 1 to up to n, and we'll use here this. This is like standard formula we can find for any number of components. Okay,
Yeah.
you got it?
Yes, ma'am.
Now let us do one more type because we have one more type norm. So let us finish. Means
Okay.
L infinity norm or max norm. L infinity norm or max norm. The L infinity norm is defined as as absolute value of largest component. What it mean? Like if we have any vector V having component V1 and V2, and if V2 second component is greater than first component, then L infinity norm of then L infinity norm of V is, just use this symbol, is equal to max of absolute value of absolute value of V1 or V2, which is greater, then we'll take that. So obviously here we have V2 is greater than V. So max norm is obviously is equal to absolute value of V in this case. Are you getting this point? Are you getting this point? L
Yes, ma'am.
infinity.
Yeah, yeah.
And we can use the standard formula for that. L infinity means infinity norm of V having n component B, max means take maximum value out of absolute value of all component. Okay.
Yeah.
Yeah. So this is L infinity norm. So we have just finished this topic, norm of a vector. So you got everything, or do you want to ask anything?
No, I got it now.
Okay. All right. So let us check the questions, and then you can send me if you have any, so that we I can prepare you practice material also. Okay?
Yeah, I'll check with them and let you know, ma'am.
Sure.
I have shared you my email ID, ma'am. Could you share the
Yeah, sure.
material and
Sure, sure.
recordings, ma'am?
Recording you can see in recording section in this class only, okay?
After updating this app, I'm unable to see, ma'am. Earlier, I was able to, but this
So
app
you can
is been
use on web
updated.
also. Okay, you
Okay.
can see on web also. Then you can find not only on app. Okay, you can use on
Okay.
laptop or in computer also. You can see directly in your class each and everything. Okay, you can find
Okay.
the study material in the study material section, while recording you will find on recording
Yeah.
section. Okay,
Okay, ma'am. I'll check. Yeah. Bye.
okay.